Okay, nice to meet you, everyone. My name is Laibao Liu. I'm from Department of Geography, but also affiliated with the Institute for Climate and Carbon Neutrality. Very happy to be here, and thank you for coming. Today, I will talk about my research for the carbon neutrality and climate change. Sorry. Okay. So I think climate change is a hot topic globally. It's a crisis. And here is a figure from the latest IPCC, like a climate report published in 2021. Here are these the three main extremes. Top left is the hot extremes, I think Hong Kong as well. And the red color indicate there's an increase. And if you see three dots here, you can say it's a very high confidence. Okay, so you can say it is worldwide. Worldwide increase of hot extremes in the historical period and from observation. Okay. So on the top right is the drought. It's about the water. So the water in the soil, more like that. And the yellow color indicate more drought. And some color like here, you can see here, is limited data because measure the soil water is not easy, unlike a temperature. So many regions do not have data, so we do not have the confidence to conclude we have increased drought. But according to the region, we have reliable data. It is strongly supported that increase in drought. And the bottom right is the flood. Heavy precipitation, more linked to flood. You can see also East Asia, as in Hong Kong as well, we have many flood, right? So you can say increase in flood as well. It is estimated about 3 billion people would be in an extremely vulnerable context to the climate change. And half of the population will be exposed to the water scarcity. Okay, and here I think is more linked to our human. It also from IPCC report, but it's a synthesis report published on 2023. And this is a metric about the heat humidity risk to the human health. So basically, the color indicate how many days per year we will be exposed to such heat humidity risks. You can see at a different global warming level, we have different magnitude, but for some tropical regions, also Hong Kong as well, you can see a large fraction of the year we have very high heat humidity risks. Okay, so go to the climate change. Carbon neutrality is regarded as a solution to address climate change, right? But what is the carbon neutrality? Here is a picture of the global carbon budget in the last 1 decade. And the left is where the carbon come from, the carbon emission. You can see about 88% from fossil fuel combustion, and 12 from the land use change, mainly the deforestation in many tropical regions. And half of them stayed in the atmosphere. So another half was actually mitigated by the land ecosystem and the ocean ecosystem. So in other words, without land and ocean, climate change will be double. So they're very important for mitigating climate change. Okay, so climate change is try to put it down. We want to remove the CO2 from the atmosphere. So to achieve carbon neutrality, either you decarbonization, right? You transition to the renewable energy or other ways, or you strengthen the land ecosystem sink or ocean system sink. So my job is actually like 2 sides. First, I look at the land ecosystem. So the value here is just the last 1 decade. But if you look at the long term, land ecosystem is the largest carbon sink. They mitigate about 30%. Okay, okay, emissions. Yeah, so my research focus, so land carbon sink is very good. They help us mitigate climate change in the past several decades. But how about the future? Well, they can still continue the role of the sink. So that's my first big question. And I want to share several news. First is a news also from MungoPie, published in 2021. And this news give a number, okay? So in the 2015 and 2016, we have a very strong El Nino event. El Nino always causes drought and hot temperature, and they kill about 2.5 billion trees in Amazon. It accounts for 1% of Amazon. And the resulting carbon emission is equivalent to UK and Australia's carbon emission. But this is not just 1 year. Because this tree died, the land ecosystem loses the capacity to continuously absorb CO2 from atmosphere. So it is a loss of capacity. And also, in just 2023 and 2024 is another strong El Nino event. Amazon experienced a never like unprecedented drought in the Amazon. Okay, and my paper look at the drought impact on the land carbon storage loss. So how much land carbon was released because of such a drought event. And in our data, we show like you can the green histogram shows the land carbon losses by drought during 1960 to 1989, and the blue one indicates the land carbon loss by drought during the recent 30 year, like 1980 to 2018, because it is increasing about 35%. And that is not the end of the story. It is a loop. You can see here, climate change causes more droughts. More drought release more carbon from the land in the atmosphere. So more CO2 in the atmosphere will further accelerate climate change. This is a positive loop. It is very dangerous. And also part of us is in most current models, like Earth system model or climate model, they didn't capture this. It's very dangerous. That means we might underestimate the future climate change. Yeah, and also I said this is drought, and this is a future projection of drought. And the brown color indicates there will be more drought in the future at a different global warming level. And this is what we usually look at. We know that, okay, global warming causes more drought in many regions. And I know we are talking about the carbon neutrality. And the CO2 removal is also a hot topic now. We want to remove the CO2 from the atmosphere by also other artificial tools like direct air capture or biomass capture or ocean salinity or many other approach. So that means there is also an assumption behind it. If we remove the CO2 from the atmosphere, the climate change would be back to the pre-industrial level. That's our assumption. But is it true? Whether the climate change can really return to the pre-industrial level as in the same way, in a symmetrical way. So that's our question. So, and, sorry, I don't know why it didn't show up. But anyway, our study indicates the soil drought can be returned, but not fully recovered. I mean, not fully returned to the pre-industrial level, just partially returned. So this is very dangerous. Okay, and the extreme is also very important to triggering some tipping points in the system. Usually we have several tipping points. For instance, one of the sites is the Amazon. Amazon trend dieback. If this Amazon trend died, release carbon to the atmosphere, accelerate climate change, very dangerous. Yeah, also we are performing a new global high impact climate event tipping point and the regional impact assessment was organized by the World Climate Research Committee and led by the professor of Gabi at the UK. I'm also part of the lead author. Yeah, next I will talk about the energy system. So energy system account about 75% of carbon emission. But how do we transition to the renewable energy system on net zero? Here is wind and solar. So this is also my topic in the energy system. Energy system, wind and solar are considered as the largest in terms of potential to mitigate the CO2 emission and the mostly cost effective. They are cheap and they have a huge potential to replace the fossil fuel at the moment, unless like a nuclear technology has a breakthrough. Yeah. Okay, so what do? We first look at the use the data from when the gust and solar radiation stations, and we do some data simulation and put it in the numerical weather research and forecasting model, and we do the 4D prediction grids like latitude, longitude, elevation, and the time. Yeah, and then we do some analysis. Yeah. Also, because I'm from Department of Geography, we are very good at mapping, huh? Very good at the geography information system. We need to consider some land use because not every land is allowed to deploy wind and solar in China. Also, we need to consider the slope. If very steep, not easy to install this wind or solar turbines. And also, nature reserve is not allowed, and urban area is also needs to be considered. Yeah, something else. And here is like a map of the land availability for deploying wind and solar in China. And that means the value means the fraction of the land pixel that is allowed to deploy wind and solar. We can say that for the desert region, definitely is very suitable. Huh? But for some cities or some other regions, not possible. Okay, so that is our number. We estimate China at 12 petawatt hour per year in terms of wind power at 100-meter wind turbine height. And the solar is about 5 times, 66, and together 78. And the 78, I'll give you a comparison. Compared to China's electricity demand in 2050, only 20% of the wind and solar can cover. And in terms of the world's electricity demand, 60% can cover. So wind and solar is no limit in the potential, only if we can make a good use of it. Okay, and this is a province level, and not good detail. Okay, next is I want to say to talking about the climate change. We think carbon neutrality is a solution, but at first I said the thing also is affected by climate change. Right? As well, for the energy system, they also be at risk from climate change. This is the news, I think in 2021 in the US, Texas, more than 4.5 billion people, a million people, cannot access electricity because of very strong storm. Also in Argentina, 2022, more than almost 1 million people cannot access electricity because the heat wave caused a quick surge in the demand, but the supply cannot catch up. So there's a power outage. Also in China, in Sichuan, there's a drought, hydropower very low level, but also a heat wave, demand very high. So they also supply demand mismatch, so power outage. As well, so in this study, we look at the future. We look at the climate change impacts on the potential supply and demand mismatch. And our research indicates result is here. The red color indicates there is a decrease in the power outage risk, and the blue color indicates there's an increase of power outage risk. You can see East Asia, including Hong Kong. If in the future we depend on the wind, and the wind energy system may be security is at risk of climate change because there's a potential mismatch between the supply and the demand. Yeah, but for solar, you can see it's also increasing in some tropical regions. Okay, and here is another ongoing study. We're not looking at everywhere. We are looking focus on the existing wind power plants. The left is this is for the wind, and we look at several parameter, several metrics for the wind power generation. First is the mean, like long-term mean power generation. The brown color indicates there is a decrease of wind power generation mean in the future because of climate change. And the top right meaning wind and solar wind power generation will be more variable. So renewable energy like wind is always criticized because of the variability, right? So the top right said, okay, more area actually is to be more variable because of climate change. And extreme is another more extreme condition. So maybe very long term, no power generation over such a period. Okay, so I think that is my take-home message. So land carbon sink is used to be a very strong climate change mitigator, but we have in the future we will experience more and increasing like unprecedented extreme, especially drought, heat wave. They will probably and maybe it's happening like weakening the efficiency of land ecosystem to mitigate climate change. But the transition to the renewable wind and solar is very promising and actionable. But meanwhile, we need to take care of the climate risks. We need to take the climate resilience into the design of the future energy system. And also some action to safeguard the land ecosystem is very useful and urgent. Yeah, that is my talk. Thank you.